Hello, good afternoon, students. Hello, good afternoon. Give me the clearance. Am I audible and visible? Okay, good afternoon, Dildar. Okay, good afternoon, Pinky Yadav, Dildar. Give me the clearance. Am I audible and visible? बताइए, am I clear? अगर clear हो तो हम start करें lecture आज का. क्या मेरी आवाज आ रही है? Am I visible? Thank you, Vijay. Thank you so much. God bless you. Okay, very good. Thank you, Pinky. So, very good afternoon to all of you, my dear student, boys and girls. Very good afternoon and welcome you to Unacademy platform. Dr. Khalil Khan here, ऑपरेटिंग सिस्टम कोर्स. और आज का हमारा टॉपिक ऑफ डिस्कशन है मेमोरी मैनेजमेंट. तो बच्चों, इफ यू रिमेंबर एंड रिकलेक्ट, पिछले क्लास में हमने स्टार्ट किया था मेमोरी मैनेजमेंट, जहां पर हमने बात की थी एड्रेसिंग और कैपेसिटी, और फिर उसके बाद हमने लोडिंग एंड लिंकिंग के बारे में बात की, देन सम बेसिक कॉन्सेप्ट्स लाइक एड्रेस बाइंडिंग. तो आज का डिस्कशन होगा एसेंशियली ऑन मेमोरी मैनेजमेंट टेक्निक्स या फिर मेमोरी मैनेजमेंट एल्गोरिथम्स, उसके ऊपर बात करेंगे. चलिए स्टार्ट करेंगे. सो बिफोर वी स्टार्ट memory management technique, let us quickly recap with regard to the basic block diagram view of memory. तो मेमोरी का बेसिक ब्लॉक डायग्राम व्यू क्या है? तो जनरली मेमोरी इज ऑर्गेनाइज्ड इन द फॉर्म ऑफ रैम चिप्स, and the RAMs are generally specified as capital N by M. If you remember, last class we have seen where we said capital N denotes the number of words and small m denotes the word length या word size. Good afternoon, Sujay. Word length denotes, small m denotes the word length or word size. ठीक है? So like for example, this is 128 by 8. That means there are 128 words and each word is of size 8 bits. हर एक वर्ड की विड्थ है 8 बिट्स इन साइज. ठीक है? So that was the view. And the various control lines available are like, for example, chip select 1, chip select 2, read line, write line, and 87. 87 is the address bus that is generally dependent on the number of words present in memory. जैसे मेमोरी में there are 128 words, I need 7-bit address, so therefore this address bus is 7 bits. अगर आप मेमोरी से रीड करना चाह रहे हो तो then the value of read signal should be 1, and if you want to perform write operation then the write signal should be 1, and the size of the database essentially effectively be equal to the size of the or width of the word. ये डिस्कशन हमने किया था पिछले क्लास में. चलिए आगे बढ़ेंगे. As I said, we are going to start the discussion with regard to memory management techniques. तो यहाँ पर I would say first functions and goals of memory manager. So functions and goals of memory manager. पर्टिकुलरली मल्टी प्रोग्राम एनवायरनमेंट में जब आप मेमोरी मैनेजर इंप्लीमेंट करना चाहो, मेमोरी मैनेजमेंट सब सिस्टम इंप्लीमेंट करना चाहो, तो सबसे पहले आपने आइडेंटिफाई करना होगा व्हाट शुड बी द फंक्शनैलिटी एंड द गोल्स. सो लेट अस ट्राई टू डिफाइन द फंक्शनैलिटी एंड द गोल्स ऑफ मेमोरी मैनेजर. तो पहले फंक्शनैलिटी की बात कर लेते हैं. द फर्स्ट फंक्शन नेचुरली इज एलोकेशन. मतलब यह है कि एज यू बेसिकली वांट टू एग्जीक्यूट एनी प्रोग्राम, आपको पता है कि द प्रोग्राम शुड बी वेल प्लेस्ड इन मेमोरी. एज पर वन ह्यूमन आर्किटेक्चर यू कैन नॉट एग्जीक्यूट द प्रोग्राम फ्रॉम एनी सेकेंडरी स्टोरेज डायरेक्टली. You have to load the program into memory. You have to bring the program into main memory. So main memory has to be allocated. It is an important resource. तो आप पहले कौन से एरिया ऑफ मेमोरी में लाओगे प्रोग्राम को, which part of memory will you bring the program into, and how do you allocate it? That is the first important function of memory manager, allocation of memory to process. Second is protection. Particularly multi-programmed operating system environment में protection is a very important issue. Diagrammatically समझने की कोशिश करते हैं what is the meaning of protection. So imagine, for example, this is a memory. Imagine this is a memory, and let's imagine this is the operating system, and these are user areas where I store user programs. So let's write this operating system. This is user program 1, user program 2, user program 3. जिस एरिया ऑफ मेमोरी में प्रोग्राम लोड होगा वो प्रोग्राम का नाम है वो एरिया ऑफ मेमोरी इज कॉल्ड एड्रेस स्पेस. दिस एड्रेस स्पेस ऑफ द प्रोसेस. So while this program runs on CPU, we have to ensure that it is accessing the instructions and data corresponding to this address space. It cannot interfere, should not interfere with other program area or with operating system. That is called protection. Protection is a very important function as far as multi-programming is concerned. No user program should be allowed to interfere with other processes. कोई दूसरे processes से interfere नहीं होना चाहिए और ना ही ऑपरेटिंग सिस्टम एरिया में इंस्ट्रक्शंस एक्सेस करना चाहिए. दैट इज कॉल्ड प्रोटेक्शन. So protection becomes essentially a very important function in multi-programming. The third important function is address translation. Particularly in multi-programming, again, हमने देखा था पहले process management में, the address generated by the program running on CPU is called logical address, also called virtual address. The address generated by the running program on CPU is called logical or virtual address, whereas the address needed for accessing the main memory, the physical memory unit, is known as physical address. So we must have a mechanism. हमें कोई mechanism होना चाहिए by way of which we convert the logical address to physical address. If you remember, we have already said this. The generated logical address is converted to the corresponding physical address by a unit called memory management unit, MMU. So every memory system, subsystem or system should have the mechanism for supporting MMU. अगर MMU ना हो तो address translation become impossible. So every multi-programmed operating system environment, memory manager should have the support for address translation mechanism. Fourth हम कहेंगे function यहाँ पर free space management. Free space management. Keeping track of free area of memory. Which part of memory is free, which part of memory is in use. Keeping track of free memory. Free space management is also one of the important function of memory manager. लास्ट में बच्चों ये कहेंगे हम डीअलोकेशन. जब प्रोग्राम अपना एग्जीक्यूशन कंप्लीट कर लेगा तो जिस एरिया में प्रोग्राम वाज लोडेड वी हैव टू रिक्लेम इट, वी हैव टू डीअलोकेट इट. सो डीअलोकेशन इज अनदर इंपॉर्टेंट फंक्शन ऑफ मेमोरी मैनेजर. सो बॉयज एंड गर्ल्स, these are the 5 important functions of memory manager. सुनिएगा फिर से. allocation, protection, address translation, free space management and deallocation. These are the important functions. ठीक है. Now these functions have to attain certain goals, has to achieve certain goals. So what are the goals of memory manager? Obviously जैसा से CPU scheduling के अपने goals थे, maximize the CPU utilization so that the throughput gets maximized, minimize the turnaround time, minimize the waiting time, minimize the response time. Those were the goals of CPU scheduler. उसी तरह we have goals of memory manager. So one obvious goal I'm very sure everybody can understand. One of the important goal of memory manager is utilization of memory, efficient, effective utilization of memory. So that is the first important goal. That is the first important goal. Effective or efficient utilization of memory. Let me write down here. Effective or efficient utilization of memory. That means the memory should not be wasted. Memory waste नहीं होना चाहिए. Wastage of memory generally is called fragmentation. So we would like to keep the fragmentation levels to the minimum possible extent. Efficiency. Wastage of memory is given a term called fragmentation. ठीक है. So there are two types of fragmentation जो हम आगे पढ़ेंगे, जिसका नाम है internal fragmentation और external fragmentation. How to minimize, how to optimize the fragmentation levels. Minimize the internal fragmentation, minimize the external fragmentation. as much less as possible the internal and external fragmentation is one of the important aspect of memory management. ठीक है? No. Sheila Kumari, you are getting confused. Efficiency is the secondary goal of operating system, not memory manager. यहाँ बात हो रही है memory manager की. Don't get confused. Convenience is the primary goal of operating system, not memory manager. Memory manager का there is no meaning in convenience. Hope you understand, Sheila. Memory manager का कोई मतलब नहीं है convenience. Convenience is the important goal of operating system, not the memory manager. Hope you understand. ठीक है. So effective and efficient utilization of memory. Second important goal is managing execution of larger program in small memory areas, small or less memory area. Example लेके समझते हैं what is the meaning of this. Like for example, imagine on disk, like we consider this is a disk, and let's say this is a memory. Observe the disk. On disk there is a program PR whose size is 100 KB, and this is a memory area which is available. Let's say the size of memory available is 60 KB. The free memory available right now is 60 KB and program size is 100 KB. So logically, when I want to execute this program of size 100 KB, I need memory of size 100K. लेकिन मान लीजिए I don't have 100 KB of free space. I have less than that, like I have 60 KB of space. So now question arises, can we manage? हम ये नहीं कह रहे हैं कि 100 KB program को आप compress करके 60 KB कर दो. No, that's not correct. Can we manage somehow the execution of a larger program of size 100 KB in otherwise available space of only 60 KB? Can we manage? If so, how? ये manage करने से क्या होगा? Eventually, I can increase the degree of multi-programming. I can load more programs. I can keep my processor busy. So that will have an impact on the throughput or efficiency of system. So there is an indirect and many advantages of supporting this goal. Somebody has said, Sheila Kumari has said, virtual memory is one of the techniques to support this goal. Very correct. Virtual memory के through हम ये कर सकते हैं. There is another technique called overlays. Overlay also support this goal. So these two are important goals of memory manager. Okay? So this is the hierarchy. This is the chart regarding functions and goals. To carry out this functionality, and support these goals, we have with us memory management techniques. उनकी classification देख लेते हैं. Memory management techniques or memory management algorithms. So essentially these are classified, memory management techniques are classified into two types. Let me write down here. It is called contiguous and the other is non-contiguous. Contiguous and non-contiguous. We'll write contiguous in short as CG. Okay? Contiguous we write in short CG and non-contiguous for our simplification we write NCG. Contiguous का मतलब क्या है? Contiguous का मतलब ये है कि it follow a sort of centralized type of allocation. I mean, I'm naming in my own terminology. Centralized allocation. मतलब the whole program as a unit will be at one place. It will not be the fact that the program is divided into parts. ऐसा ना होगा कि program you divide into parts and you store different parts of the program in different areas of memory. ऐसा. The whole program as a unit will be at one place, centrally located at one place. अगर 100 KB का program हो तो सारा 100 KB का program एक ही जगह रहेगा, contiguously रहेगा. ये है contiguous. Non-contiguous, it is not necessary that the whole program should be at one place. I may follow a distributed approach or decentralized approach. Distributed का मतलब यह है I may divide my program into parts, units, segments, pages and I store different parts of the program in different areas. कुछ part of program यहाँ रहेगा, कुछ और जगह रहेगा, कुछ और जगह रहेगा. ये है decentralized approach. So therefore, in my terminology, I would name non-contiguous allocation as like distributed approach. Different parts of the program are distributed, are decentralized. It is not at one place, may not be at one place. There are techniques that come under contiguous allocation. What are they, for example? The very first technique that comes under is called partitions. And partitions are of two types. Partitions are of two types. One is called fixed partitions, and the other is called variable partition. And second is called overlays. Okay? And third is swapping systems. Fixed partitions. I mean the contiguous allocation. Under non-contiguous, I can have techniques in the form of paging. There are different forms of paging. I have simple paging, paging with TLB, right? And then we have paging with hashing, hash paging, inverted paging, multi-level paging, and so on. And then we have segmentation, second approach. Segmentation. And we have a combined approach of both, segmented paging. Combined approach of both, it is called segmented paging. Why should we have segmented paging? What is the need for combining? That we shall see later point of time when we take up that topic. और लास्ट में बच्चों ये होगा हमारा जो लास्ट टेक्निक होगी विथ रिगार्ड टू नॉन कंटिन्यूअस एलोकेशन, वो है वर्चुअल मेमोरी. वी राइट इन शॉर्ट VM. तो बच्चों कहने का मतलब ये है, जब आप मेमोरी मैनेजमेंट पढ़ रहे हो फ्रॉम द गेट एग्जाम पर्सपेक्टिव, तो ये है आपका बेसिक डिस्कशन जो आपने फेमिलराइज करना है अपने आप को. You have to study all this. You need to be knowledgeable with regard to partitions, fixed and variable partitions. फिर overlays. Then what are swapping systems? Swapping में both contiguous भी होगा, non-contiguous भी होगा. Let me tell you. Then I have various forms of paging. Paging like simple paging, paging with TLB, inverted paging, hashed paging, multi-level paging. ठीक है? Different form of paging. Then we even have the concept of shared pages. फिर सेगमेंटेशन, सेगमेंटेड पेजिंग, वर्चुअल मेमोरी. ये पूरा आपकी टैक्सोनॉमी है. ये आपने ये टॉपिक्स है जो मेमोरी मैनेजमेंट में एज फार एज गेट एग्जाम प्रिपरेशन इज कंसर्न. तो चलिए सबसे पहले स्टार्ट करते हैं पार्टीशंस. लॉट ऑफ क्वेश्चंस वर आस्क्ड इन अर्लियर पेपर्स बेस्ड ऑन पार्टीशंस, फिक्स्ड एंड वेरिएबल. चलिए स्ट्रेट फॉरवर्ड डिस्कशन स्टार्ट करते हैं, स्टार्टिंग फर्स्ट विथ फिक्स्ड पार्टीशंस. स्टार्टिंग विथ फर्स्ट फिक्स्ड पार्टीशन. सो लेट मी राइट हियर fixed partitions. ठीक है, फाइंड हो गया है ये. दिस शुड बी लाइक X. Fixed partitions. Generally in the literature, fixed partitions is also called MFT. जो उसका ओरिजिनल नेम था वो टेक्निक का नाम है MFT. We'll discuss शीला कुमारी overlays बाद में क्या है. I'll talk about it. First we'll complete fixed partitions. MFT का मतलब है, फुल फॉर्म है मल्टी प्रोग्रामिंग विथ फिक्स्ड टास्क्स. मल्टी प्रोग्रामिंग विथ फिक्स्ड टास्क्स. क्या है मतलब फिक्स्ड टास्क? लेट अस सी. हम पहले लेक्चर में we have seen that task is also called program. Program, process, task, these are all synonyms. So you may call task, you may call program, you may call process. All are essentially the same. तो चलिए बच्चों स्टार्ट करेंगे डिस्कशन विथ रिगार्ड टू फिक्स्ड पार्टीशन. सो अगेन आई वुड एम्फसाइज दैट लेट्स से दिस इज माय मेमोरी एरिया. दिस इज माय मेमोरी इन ब्लॉक डायग्राम फॉर्म. ठीक है. जनरली एज आई सेड मेमोरी विल बी डिवाइडेड इनटू टू पार्ट्स, राइट. And the first area is called S area, system area, जहां पर होगा ऑपरेटिंग सिस्टम. and the other area of memory is called user area, U area, user area. It is the user area which is responsible for storing user programs. So boys and girls, हमेशा याद रखिए, managing memory means managing user area. By whom? By operating system memory manager. By operating system memory manager. So different techniques will have different ways of managing this user area. So boys and girls, I am taking an enlarged view of this user area. Enlarged matlab, you can say invariably I am zooming out this user area, user space. So what is going to happen in fixed partitions in user area? What is going to happen in fixed partitions? So let us write down here. The user area, point number 1, will be divided into fixed number of units which are called partitions. Memory will be divided into fixed units known as partitions. Some people even call it as blocks, whatever it is. Fixed number of partition. देखिएगा 1, 2, 3, 4, 5, 6. I have 6 partitions. The user area is divided into fixed number of blocks, fixed number of partitions of different sizes, maybe or maybe same size. कुछ भी हो सकता है. Like imagine, for example, in our case, let's imagine the size of this partition is 80 KB. Let's say this is 120 KB. Let's say this is 30 KB. And let's say this is some 200 KB. And let's say this is some 70 KB. ठीक है? And अच्छा 70 and this is very near 80, so I will slightly change this. Let's imagine, for example, this is 150 KB, and let's say this is some 300 KB. I've divided the user area into fixed number of chunks, fixed number of blocks known as partitions. The rule is that, remember the rule, the important rule for fixed partition is that one partition, one program or one process. One partition, one process. The fixed rule. I cannot have multiple processes, multiple programs loaded in one partition, and neither I can have a process occupying more than one partition. 1:1. एक program सिर्फ एक partition में आएगा. I cannot have 2 programs in one partition. I cannot have a program occupying 2 partitions. ठीक है? 1:1. तो ये पार्टीशन की साइज जब 80 KB होगी तो इसका मतलब ये है, इन दिस पार्टीशन आई कैन नॉट लोड ए प्रोग्राम ऑफ साइज मोर देन 80 K. इस पार्टीशन में हम कोई भी प्रोग्राम ग्रेटर देन 80 KB लोड नहीं कर सकते. साइज 80. सो एनी प्रोग्राम ऑफ साइज लेस देन और इक्वल टू 80 KB विल गेट प्लेस्ड हियर. एनी प्रोग्राम ऑफ साइज 120 KB एटलीस्ट विल गेट प्लेस्ड हियर. यहां 30 ऐसा है. अब यहां पर हमने सम इश्यूज देखना होगा, लाइक issues like, for example, allocation देखना होगा, and then we also have to look into what is called protection. Protection कैसे करोगे? जब एक प्रोग्राम यहाँ पर लोड करोगे कोई पार्टीशन में, how do you make sure that it does not interfere with other partitions or other program areas? That is called protection. Generally, protection is ensured by using what is called limit registers, base registers, and limit registers. So how do base and limit registers are going to use? Look at this. Base का मतलब यह है कि starting address of the partition, start address of partition, and limit is the size of partition. Size of partition. This is the hardware for protection. So you can name this. You can name this as protection hardware. Protection hardware. Oh my God, काफी बड़ा हो गया. ठीक है? So that is called protection hardware. So, or maybe here we can say protection hardware. So how is protection done? Please have a look. Limit is size, correct. तो रनिंग प्रोग्राम ऑन सीपीयू, जो भी प्रोग्राम पार्टीशन में लोडेड है और वो जब रन कर रहा है, सो बेस, लाइक फॉर एग्जांपल आई एम टेलिंग, ये इसका बेस है, स्टार्टिंग एड्रेस, and the size is the limit. That is very simple. तो जो भी प्रोग्राम स्टोर होगा, लोड होगा पार्टीशन में, that will generate the address. So we want to ascertain, we want to find out whether this address is within the valid range of the partition or not. तो हम क्या करेंगे? First we'll see whether it is greater than or equal to base. Diagram देखिएगा. It should be greater than or equal to base. If it is no, अगर वो base से less है, फिर से देख लीजिएगा. Base से less है मतलब it is interfering with the previous partition, which is not correct. So if it is less than, greater than or equal to, if it is yes, we allow. Otherwise, no means it's a trap. Trap matlab error, error to operating system. Error is thrown to operating system. Interrupt is thrown to operating system, saying that this is a illegal access. ये illegal access है. Otherwise, if it is yes, then we check whether the generated address say x, अगर ये address मान लीजिए x है, whether this x is within base plus limit, क्योंकि base plus limit will specify base plus limit. If you add, it specify this range. So x has to be within this range. So if it is not within range, no, again it's a trap. Otherwise, if it is yes, allowed to access physical memory. These are simple protection hardware for ensuring that whatever address is generated by the program is within the limits. ये प्रोटेक्शन ऐसे इंश्योर होगा. तो प्रोटेक्शन के लिए जो हार्डवेयर हमें चाहिए वो होगा बेस प्लस लिमिट रजिस्टर. दैट्स इट. एक बेस रजिस्टर और बेस प्लस लिमिट रजिस्टर. दैट्स इट द हार्डवेयर. लेकिन व्हाट इज प्राइमरली इंपॉर्टेंट, जो ज्यादा इंपॉर्टेंट है हमें डिस्कस करने का, वो है एलोकेशन. तो यहां पर हम बात करेंगे एलोकेशन. इज वेरी इंपॉर्टेंट, सुपर डुपर इंपॉर्टेंट. Lot of questions in earlier papers based on this functionality, allocation. ठीक है. Allocation का मतलब पहले समझा देता हूं. Like for example, I am receiving a new process of size, let us say 25 KB. एक प्रोग्राम है जिसका साइज है 25 KB. हाँ बिल्कुल, segmentation also will cover here, Sheila. There is a program of size 25 KB. And we want to execute this program, we want to load this program into the memory under fixed partitions. As you see here, हम यहाँ भी load कर सकते हैं, यहाँ भी कर सकते हैं, यहाँ भी कर सकते हैं. Every partition, if all of them are free, initially I can load in any of them. तो हमें डिसाइड करना होगा, मेमोरी मैनेजर को डिसाइड करना होगा कि कौन से पार्टीशन में ये प्रोग्राम लोड करनी है. There should be some policy, there should be some algorithm, there should be some strategy to decide that. And that is done by some policies which are called partition allocation policies. Partition allocation policies. Policies to decide which partition are we going to accommodate the process in. Partition allocation policies. ठीक है? So we have partition allocation policies. If you remember and recollect, you might have studied earlier, like first fit. Then if we have best fit, and we have worst fit. Three important policies. Of course, there are others also, but they are not that important. These three are important. First fit, best fit, and worst fit. Discussion करते हैं, understand करते हैं worst fit और first fit और next और best fit का मतलब क्या है. First fit, as the name say, जब भी कोई प्रोग्राम को आप allocate करोगे, you are going to search right from the first partition that is big enough to accommodate the process. So that's what we say first fit has. First, free, big enough. Three words में कह रहा हूं. First, free, big enough. Start searching from the first partition which is free and big enough to accommodate the process. First fit. तो यहां पर अगर मान लीजिए when all partitions are free, 25 KB will get placed in 80 KB. How? I will allocate 25 KB and the remaining area जो है 80 minus 25 कितना होगा? 55 KB. 55 KB of space internally within the partition will go waste. Internally, after accommodating the process, जितनी भी memory waste हो रही है, जितने भी leftover memory है, that will go waste, and that is called internal fragmentation. Internal fragmentation is the leftover memory within the partition after the accommodation of the process. वो है internal fragmentation. Then best fit, जैसा नाम है best. Best with respect to what? Best with respect to size. Smallest, free, big enough. यह है first free big enough. अगर आप चाहो तो इसे शॉर्ट में मैं यहां पे लिख सकता हूं. This is first free big enough, and this is smallest free big enough. स्मॉलेस्ट ऑफ ऑल दी अवेलेबल, तो जितने भी पार्टीशन फ्री अवेलेबल होंगे उसमें हम स्मॉलेस्ट अलोकेट करेंगे। जैसे इफ ऑल आर फ्री 25 KB, स्मॉलेस्ट मतलब 30 KB में जाएगा। अगर 30 KB इन यूज है तो नेक्स्ट स्मॉलेस्ट में जाएगा, लाइक 80 KB। अगर वो भी इन यूज हो तो नेक्स्ट स्मॉलेस्ट में जाएगा, दैट इज बेस्ट फिट। फिर लास्ट में है वर्स्ट फिट, लार्जेस्ट फ्री बिग इनफ, लार्जेस्ट फ्री बिग इनफ। अमंग ऑल द पार्टीशन सबसे जो लार्जेस्ट होगा पार्टीशन उसमें आप प्रोसेस को अलोकेट करोगे, लार्जेस्ट फ्री बिग इनफ। सो बॉयज एंड गर्ल्स, दीज आर द 3 एलोकेशन पॉलिसीज, फर्स्ट फिट, बेस्ट फिट एंड वर्स्ट फिट। तो चलिए 3 इंपॉर्टेंट फंक्शंस हम देख चुके हैं। एंड हाउ टू कीप ट्रैक ऑफ फ्री पार्टीशंस, every partition will be associated with a bit, you can say with a bit, one binary bit that can take values of 0, 1. If the value of the bit is 0, the partition is free. If the value of bit is 1, the partition in use, a simple convention. So this is for keeping track of free partitions. So boys and girls, we have seen for fixed partition, partition allocation policies and the protection mechanism. Now in respect of this, what we have to discuss is the performance of this. So let's write here. Performance of fixed partitions. Or maybe I will write down with this. Performance of fixed partitions. Performance of fixed partitions. This is becoming too large. I don't know why. Let me try again. ठीक है. I don't know, for this is writing fine, so fixed partitions. ठीक है, तो चलिए स्टार्ट करते हैं. सबसे पहला होगा इश्यू ऑफ इंटरनल फ्रैगमेंटेशन. इंटरनल फ्रैगमेंटेशन. Generally, I write internal fragmentation as IF. Can there be a potential possibility of having internal fragmentation here? बोलिएगा, बोलिए. बोलिए, can we go with internal fragmentation? Can we have internal fragmentation? हाँ बिल्कुल, जैसे हमने पिछले एग्जाम्पल में कहा 25 kb when it gets accommodated in 30 kb partition, 5 kb will be internal fragmentation. If it get accommodated in 80 kb, 55 kb will be internal fragmentation. So therefore I say that this approach will have internal fragmentation. Second, can there be a potential possibility of having external fragmentation here? क्या यहां पर external fragmentation हो सकता है या नहीं हो सकता है? Let us try to see. External fragmentation. External fragmentation is the memory which is left over between the partition. देखिए, डिजाइन और आर्किटेक्चर फिक्स पार्टीशन का ऐसा है कि between two partition there is no scope of having any free space. Between two partition there is no scope of having any free space. इसका डिजाइन ही ऐसा ही है. तो एक्सटर्नल इज ऑलवेज आउटसाइड द पार्टीशन, और आउटसाइड द पार्टीशन कोई स्कोप रहने की जरूरी है ही नहीं, कोई पॉसिबिलिटी फ्री स्पेस रहने की कोई पॉसिबिलिटी नहीं है. So therefore this approach does not suffer from external fragmentation. No external fragmentation. ठीक है. Then third is degree of multiprogramming. क्या कहोगे आप degree of multiprogramming? Degree of multiprogramming is actually number of processes present in memory. कितने processes memory में होंगे degree of multiprogramming. So that is limited to what? Please observe, limited to the number of partitions. अगर आप मेमोरी को और यूजर एरिया को डिवाइड करोगे बेसिकली इन 1 2 3 4 5 6 पार्टीशंस में, then at that this implies that I cannot have more than 6 programs or 6 processes present in memory at any time. I cannot have. So degree of multi-programming is always limited. Limited to what? Limited to the number of partitions. अगर मेरे सिस्टम में 6 पार्टीशंस होंगे तो डिग्री ऑफ मल्टी प्रोग्रामिंग इज ऑलवेज लिमिटेड टू नंबर ऑफ पार्टीशंस. ये भी एक लिमिटेशन है. इट हैज इंटरनल फ्रैगमेंटेशन, ऑफ कोर्स नो एक्सटर्नल फ्रैगमेंटेशन, लेकिन डिग्री ऑफ मल्टी प्रोग्रामिंग इज लिमिटेड. देन नेक्स्ट, मैक्सिमम प्रोसेस साइज रनेबल. मैक्सिमम प्रोसेस साइज जो रनेबल है दैट इज ऑल्सो लिमिटेड टू व्हाट? मैक्सिमम पार्टीशन साइज. सो आई वुड से लिमिटेड टू मैक्सिमम पार्टीशन साइज. लिमिटेड टू मैक्सिमम पार्टीशन साइज. जब आप डिवाइड करो पार्टीशन को, बेसिकली यू कैन हैव अ लुक एट हियर. When my maximum partition size is 300 KB, I cannot execute a program of size 300 KB. Limited to maximum partition size. Last में हम देखेंगे which allocation policy is better, superior. Fifth performance issue. Allocation policy. Which allocation policy? Best fit should be the best, because best fit will lead to less internal fragmentation, is it not? बेस्ट फिट से आप एलोकेट करोगे तो इंटरनल फ्रैगमेंटेशन जो लीड होगा, जो आएगा, वो कम रहेगा, राइट? सो इट विल हैव लेस इंटरनल फ्रैगमेंटेशन. सो देयरफॉर आई से बेस्ट फिट इज सुपीरियर. व्हाई? ड्यू टू लेस इंटरनल फ्रैगमेंटेशन. तो बच्चों ये है परफॉर्मेंस ऑफ fixed partitions. We have internal fragmentation, we don't have external fragmentation. Degree of multi-programming limited है, maximum process size भी limited है, और the only advantage is I have best fit leading to less internal fragmentation. तो ये जो problems है, if you want to overcome these problems, if you want to remove these problems, then I can go for this next allocation policy, next partitioning technique, which is called, let me write here, next partition, the second one, let me write it here. Variable partitions. Variable partitions. So let's underline this. Variable partitions is actually known in the literature as, let me write, it is called MVT. MVT का मतलब है multi programming with variable tasks. MFT multi programming with fixed tasks. MVT multi programming with variable tasks. And in my terminology, I also call this as dynamic partitioning. मेरी अपनी टर्मिनोलॉजी में मैं कहूंगा दिस इज डायनामिक पार्टीशनिंग. एंड द अर्लियर वन, ये जो था, दिस इज स्टैटिक पार्टीशनिंग, स्टैटिक अप्रोच. व्हाई? नंबर ऑफ पार्टीशंस आर फिक्स्ड, सो दैट्स व्हाई इट इज स्टैटिक, whereas the other one is dynamic. So what happens in variable partition, we have to see. So at the outset, I will assume this is my user area. Please follow me carefully, boys and girls. Let's imagine this is a user area. Initially, boys and girls, please follow. Initially, I assume this whole user area as one free hole. One free hole, HOLE, hole. एक होल कंसिडर करेंगे, एक फ्री एरिया कंसिडर करेंगे. इनिशियली आई हैव 0 पार्टीशंस, कोई पार्टीशन अवेलेबल नहीं होगा, कोई प्रोसेस, क्योंकि कोई प्रोसेस लोड ही नहीं किया आप. सो देयरफॉर initially I assume there are no partitions. And now imagine, for example, at some point of time t, listen to me, at some point of time t, I have the following process requests. So let me write, these are the following process requests. These requests are coming from disk. What request? Like first process say I want 75 KB. Second process P2 say I want 125 kb. Third process say I want 20 kb. Fourth process say I want 283 kb. And next process say 180 kb. And next process say 50 kb, something like this. These are the process requests that are pending right now. How many? 1, 2, 3, 4, 5, 6, 6 process. तो हम क्या करेंगे अब सुनिएगा. At time 0, I will first load P1 75 kb, P1, P2, P3, P4, P5, P6. So I load P1. How? I will dynamically create one partition exactly of size 75 kb and place it here P1 75 kb. Next I have 125 kb. एक partition create करेंगे exactly of size 125 kb and I will place P2 here. ये है 125 kb. Then I have 20 kb. So again I will create one more partition of size 20 kb and I will place P3 here 20 kb. Then I have 283 kb. चलिए और एक partition create कर लीजिएगा of size 283 kb. P4. So boys and girls, please understand that initially I have 0 partitions. Now I have 1, 2, 3, 4 partitions and 1 free hole. ये है scenario. 4 partitions and 1 free hole. Next I will take 180k. Boys and girls, 180k. Imagine this 180k. P5. 180 kb. Then I have next 50 kb. Last P6 50 kb. And let's imagine this is around 400 kb. I say this is a free hole. So initially I have 0 partitions. Now I have 6 partitions and 1 free hole. This is a scenario. तो अब इसके बाद क्या होगा? Like for example, I have CPU and the processes starts getting scheduled onto CPU. The CPU. Processes may run in any order. शायद कोई P1 run करेगा, then P2, then P3, then P4, then P5. They may run, they may get preempted, and then any process can run any number of times and it can get completed in any order. कोई भी process पहले complete होगा या कोई भी process बाद में complete हो सकता है. Sheila Kumari, whatever be the size of user area, I don't mind. It may be anything. It may be anything. So in any order, the processes may run on CPU and get completed. Now we have an interesting issue here. We have an interesting issue. Like for example, imagine some processes complete. Like imagine for example, P5 got completed. Then after that, P3 got completed. Area हम mark करेंगे. This was 20 kb. P5 1, 2, 3, 4, 5, 180 kb. These two processes got completed. So kindly observe, boys and girls, now I have 3 free holes. 1, 2, 3 free holes. 1, 2, 3 free holes. Now at this moment, अब यहां पर हम मानेंगे, I have received a new process. Let's imagine I have received a new process. Let's say the size of the new process is 18 kb. Please follow this. Very interesting and important. Now at this point of time, जबकि दो processes complete होके आ चुके हैं, and these processes are still in memory, at this moment I got a new process by name 18 kb and want to get injected into memory, want to get loaded into memory. हमें decide करना होगा in which free hole are we going to place it and how are we going to place. कौन से free hole में accommodate करेंगे और कैसे करेंगे. So for that, again we will use the same allocation policies that we discussed earlier. I can place it using first fit, I can place it using best fit, or I can even place it using worst fit. Any of them. First fit or best fit or worst fit. Using first fit, I will place in 80k, 20k. How? Divide. Very important. Please follow. I will divide this into 2 parts. One exactly of size 18 kb and the remaining will be a new free hole of size 2 kb. New free hole. वहां पर इंटरनल फ्रैगमेंटेशन था, यहां पर न्यू फ्री होल बनेगा ऑफ साइज 2 kb. ये डिफरेंस है. इफ आई वुड हैव प्लेस्ड फॉर एग्जांपल 18 kb यूजिंग बेस्ट फिट, फिर भी यही आएगा. अगर वर्स्ट फिट होता तो आई वुड हैव प्लेस्ड इन 400k. कैसे? डिवाइडिंग 1 into ऑफ साइज 18 kb and the remaining will be of size 382 kb. 382 or 372, sorry, whatever it is. 382 or 372. So that will be the new freehold. This is the difference. That's why it is dynamic. Initially started with 0 partition, then I had 6 partitions. Now I have 1, 2, 3, 4 partitions, 1, 2, 3, 3 freeholds like this. So same allocation policies can be used, first fit, best fit and worst fit. Protection का भी वही mechanism रहेगा, base and limit registers. So the only way is dynamic partition. Partitions are created dynamically at runtime. That is the only part. So based on this, boys and girls, we have to ascertain, we have to find out, we have to see what is the performance of this with regard to fixed partitions. चलिए next slide में understand करते हैं performance. So let us write here. ठीक है? So let me write performance of MVT. ठीक है? MVT मतलब variable partitions. तो सबसे पहले फिर वही बात होगी, एज वी सेड अर्लियर, नंबर 1 इंटरनल फ्रैगमेंटेशन. आपने मुझे कहना है, आपने मुझे बताना है कि कैन वेरिएबल पार्टीशन हैव द स्कोप ऑफ हैविंग इंटरनल फ्रैगमेंटेशन. बोलिएगा प्लीज, कैन वी हैव इंटरनल फ्रैगमेंटेशन? बोलिए. शीला कुमारी, यू आर सेइंग अर्लियर इंटरनल फ्रैगमेंटेशन नहीं होगा सर, तो आप कहिए, डोंट आस्क मी द क्वेश्चन. कैन वी हैव इंटरनल फ्रैगमेंटेशन इन वेरिएबल पार्टीशंस, यस और नो? We cannot have, there is no scope. कोई पॉसिबिलिटी है नहीं है यहां पर इंटरनल फ्रैगमेंटेशन रहने की. नो इंटरनल फ्रैगमेंटेशन. क्वेश्चन इज कैन वी हैव एक्सटर्नल फ्रैगमेंटेशन? जैसे मैंने कहा था पिछले फिक्स पार्टीशंस में कि एक्सटर्नल फ्रैगमेंटेशन के लिए देयर शुड बी स्कोप ऑफ हैविंग फ्री मेमोरी बिटवीन द पार्टीशंस. अब देखिएगा पिछली स्लाइड में, हियर दिस इमेजिन दिस इज 20 KB फ्री, 180 KB फ्री एंड 400 KB फ्री. प्लीज फॉलो मी. 400 KB is free, 180 KB is free, 20 KB. तो टोटल फ्री मेमोरी जो है 400 plus 200, 600 KB. 600 KB is free, boys and girls. I have 600 KB free memory right now across the partition, between the partitions. Now at this juncture, at this point of time, if I receive a new process of size, let us say 650 KB, 550 KB. Maximum is 400 now, so I will write like I receive a new process of size 450 KB. Please follow, boys and girls. Total free area is 600 KB. जनरली देखा हूं मैं कि बच्चों को थोड़ा कंफ्यूजन होगा एक्सटर्नल फ्रैगमेंटेशन के लिए, समझा रहा हूं, समझिएगा. टोटल फ्री स्पेस इज 600K. नाउ प्रोसेस साइज 450K. क्वेश्चन इज कैन बी प्लेस दिस प्रोसेस ऑफ 450 इन 600KB? नो, वी कैन नॉट. क्यों? बिकॉज आई वांट 450K कंटिग्यूअस. मेरे पास मैक्सिमम जो कंटिग्यूअस एरिया है वो है 400K. So I cannot accommodate this 450 here. Neither I can take 400 here and place 50 here. It's not possible. So even though total free memory is much higher, much larger than the requirement, still we are telling the process we are sorry, we cannot accommodate. So naturally this is also wastage of memory. ये जो fragmentation होगा, जो outside the partitions होगा, that is called external fragmentation. So this approach suffers from external fragmentation. External fragmentation. Then what are the other issues, boys and girls? The other issues are like degree of multi-programming. Now it is dynamic partitioning. So therefore, we would say degree of multi-programming is flexible. Flexible in comparison to fixed partitions. In comparison to fixed partition, it is flexible. And then fourth, maximum process size runnable. What is the maximum process size runnable? That will also become flexible. Unlike it was earlier, unlike earlier occasion, it was limited, but now this is flexible. Because logically in the beginning I can load programs of much greater size, so therefore flexible. Then which allocation policy should be better? Which allocation policy should be better or superior here? बोलिए. Which allocation policy? Using first fit or best fit or next fit, which one is better in terms of having less fragmentation? If I go with, listen to me, if I go with best fit like earlier occasion, it will result in creating small free holes. It will result in creating small free holes, and that small free holes will contribute to external fragmentation, will add on to external fragmentation. मतलब best fit से आप allocate करोगे तो it will create small free holes, और वो free holes will go in external fragmentation. It may not accommodate a process. So to avoid creating small free holes and accommodate new process, bigger process, I should go for worst fit. Worst fit. So I may not be wrong if I say worst fit may perform better than best fit in the case of variable partitions. लेकिन worst fit का भी एक drawback होगा कि worst fit means you are going to use largest partition, मतलब you are losing the largest partition for a bigger incoming process. But by and large, keeping track of this trade-off, you can say, however, worst fit may be better than best fit for variable partitions. तो ये है बच्चों with regard to, so therefore here I may say worst fit may be better. So these are the issues. So we can say that the only problem, the only challenge that is remaining here is external fragmentation. So boys and girls, the only challenge that is remaining here to be solved is external fragmentation. So now the question is, what are the solutions? What are the solutions for solving the problem of external fragmentation? So if you observe, there are two solutions. One is called compaction. What is compaction? Compaction is also called defragmentation. We can take a simple example to explain the idea of compaction. We can take a small scenario. Imagine, for example, this is the memory area right now. Okay. These are the partitions. Okay. So let's say this is some program P1, whatever be size, we don't care. This program P2, whatever be the size, and this program P3. So at this point of time, without losing any generality, let us say it is 100 KB and let's say it's 50 KB free hole. So there are three programs right now, P1, P2, P3, and there are two free holes, 100 KB and 50 KB. At this point of time, the total free memory, if you write total free memory, is 150K. Okay? And I have a new process to get accommodated of size, let's say 110K. And you can see we cannot place it. Okay, 110K should be contiguous. And I don't have 110K contiguous. So therefore, this 150 we say is going waste in the form of external fragmentation. अगर आप ये external fragmentation avoid करना चाह रहे हो, then I have to go for a process called compaction. Compaction से क्या करेंगे आप? You are gonna bring all the programs at one end. जितने भी programs होंगे, you bring it to one end of memory and thereby create a one big free hole at the other end. You are going to relocate. आप program को relocate करोगे, move करोगे from its current location to some location contiguously. एक के बाद एक programs को store कर लो ताकि दूसरा area of memory totally become free. Like when I carry out compaction on this memory segment, then what is going to happen? Check. So this is a user area again. After compaction, क्या बनेगा ये? After compaction, what is going to happen is, let me write. So I will have P1 as it is, and immediately after P1 I will store P2, and immediately after P2 I will store P3. So P1 as usual here, P2 get relocated immediately after P1, P3 get relocated immediately after P3. This is called relocation. And then this area, free area, will become one big free hole of size 150 KB, which can easily accommodate 110K. ये है compaction. So compaction is one of the solution for solving the problem of external fragmentation. लेकिन compaction is not a desirable solution. Why? ये solution तो है, लेकिन it is not a desirable solution. Why? Because compaction is a time consuming operation. एक time consuming है. It will take some time to basically relocate the program, move the program from one area to another area. And secondly, second drawback of compaction is it requires program to support what is called runtime address binding. Programs that support runtime address binding, only compaction is possible. अगर आपके programs are following static address binding like compile time or load time, compaction is not possible. Compaction possible नहीं है. ठीक है? ये है philosophy of compaction. So in view of these requirements of compaction, what do you say? What is the other solution for overcoming external fragmentation? External fragmentation को overcome करने का और क्या solution है? दूसरा solution है go for non-contiguous allocation. See, problem of compaction is arising due to contiguity. I want contiguous allocation, check. I want contiguous free memory. If I have one free hole, one free hole, one free hole, why should I have the restriction that the whole program should be at one place? Let us remove that restriction. अगर यहां पर कुछ मेमोरी अवेलेबल हो, कुछ पार्ट ऑफ द प्रोग्राम वहां स्टोर कर दीजिएगा, कोई दूसरे एरिया में कुछ और मेमोरी हो, वहां पर कुछ पार्ट ऑफ प्रोग्राम स्टोर कर दीजिएगा. इसी तरह प्रोग्राम में भी डिवाइडेड इनटू पार्ट्स, इनटू मॉड्यूल्स, इनटू सेगमेंट्स, इनटू पेजेस, एंड इट मे बी डिस्ट्रीब्यूटेड इन द मेमोरी एट डिफरेंट प्लेसेस. ये है नॉन कंटीग्यूअस एलोकेशन. सो बॉयज एंड गर्ल्स, कहने का मतलब ये है, वन ऑफ द बेसिक गोल फॉर हैविंग नॉन कंटीग्यूअस एलोकेशन, one of the basic objective of having non-contiguous allocation is to basically overcome the problem of external fragmentation. Okay? So under that regime we have techniques like paging, segmentation, segmented paging, virtual memory. So but before we start the discussion on non-contiguous allocation, let us quickly have to try to have some review with regard to some questions. So यहाँ पर एक diagram है, देखिएगा, explaining, this is the explanation of what you say non-contiguous allocation. Sorry, this is explanation of variable partitions. Variable partitions. Diagram समझने की कोशिश करते हैं. I have one partition of size 2 MB, another partition of size 6 MB, and this is process 3 of size 3 MB, and so on. After that, P2 and P4 got completed. Look at that, P2 and P4 got completed. So this has become a whole of size 6 MB. This has become a whole of 4 MB. इसके बाद P6 and P7 arrived. They got accommodated. P6 got placed here, 4 MB. Two whole remaining of size 2 MB, because the original size 6 MB था. यहाँ पर हमने P6 को स्टोर किया. This has become 2 MB. And P7 got accommodated here, 3 MB. So I have a whole of size 1 MB. क्योंकि total size this was 4 MB. So 3 MB का process है, 1 MB become a whole. दो holes है. Now P3 MB arrive, P3 comes, P8 comes. So can't load P8. P8 of size 3 MB cannot. हालांकि we have enough memory of size 3 MB. यहाँ 2 MB free है, यहाँ 1 MB free है. So this is the demonstration of external fragmentation. This is a clear demonstration of external fragmentation. ठीक है? The clear diagram is a clear illustration of external fragmentation. तो चलिए, अब मान के चल रहा हूं कि आपने external fragmentation समझा होगा, तो जल्दी मुझे इसका आंसर बता दीजिएगा बच्चों. The capacity of memory unit is defined by the number of words multiplied by the number of bits per word. How many separate address and data lines are needed for memory? Gate question है. 4K by 16. तो मेमोरी कैपेसिटी जो है 4K by 16 है, देखिएगा. तो इसको सपोर्ट करने के लिए मुझे एड्रेस और डेटा बस की साइजेस क्या होगी? बोलिए. What should be the size of the address bus and what should be the size of the data bus? Come on, tell me, boys and girls, fast. What will be the size of address bus and data bus? There are 4 kilowords, each word of size 16 bits, each word of size 16 bits. तो 4K को एक्सेस करने के लिए मुझे क्या लगेगा? बोलिए. 4K को एक्सेस करने के लिए मुझे लगेंगे 12 bits. और word length will depend, the data bus will depend on the word size. So word size 16 bits. So 12 bits, 12 address bits and 16 data lines. That's correct. That's correct. Many people are correct. Next question. Answer this question, boys and girls. इसका आंसर बताइएगा। कंसिडर मेमोरी सिस्टम हैविंग 6 पार्टीशंस ऑफ साइज 200K। चलिए यहां पे डायग्राम बनाते हैं। वी हैव पार्टीशंस, 200K का पार्टीशन है, $200K, then $400K, then $600K, then $500K, then $300K, and $250K. So let me mark. This is $200K, and this is $400K, and this is $600K, and this is $500K, this is $300K, and this is $250K. Check. There are 4 processes of size. First, 357, 210, 468, 90, 49K. Using best fit allocation policy, what partitions are not allocated remains unallocated? Get question है, मैं options यहाँ पे नहीं लाया हूँ, तो आपने मुझे बताना है कि what partitions are not allocated, कौन से partitions allocate नहीं होंगे। चलिए करते हैं best fit। 357 using best fit will naturally go into 400K. So I will put process 357 will come here. Then 210K fixed partition सही है, 210K will move into 300K, sorry 250K, P 210K best fit. Then 468K will move into 500K, process 468. Then 49K naturally will move into 200K, P49. So what partitions remain unallocated? सुनिएगा, the partitions that remain unallocated are 600K and 300K. That's it. That's the answer for this. Kishori Shyam, check why you have gone wrong. 300 and 600 remains unallocated. ये allocation नहीं हुआ ये दोनों, ठीक है, using best fit policy. चलिए नेक्स्ट क्वेश्चन देखेंगे। ये नहीं, हाँ इसका आंसर देखिएगा। टेल मी द आंसर फॉर दिस। In a variable size fixed partition memory management scheme or technique, internal fragmentation occurs when? Tell me the answer for this. Mr. Datta, if you follow the lectures, make your long notes, short notes for revision, and then if you work out PYQs, that is more than sufficient enough. There is no need for DPP, there is no need for other practice questions. टेस्ट सीरीज फॉर टाइम मैनेजमेंट के लिए कर लीजिएगा, चेकिंग लेवल ऑफ प्रिपरेशन के लिए चेक कर लीजिएगा, ठीक है। तो देयर इज नो नीड ऑफ एनी अदर थिंग। टेल मी द आंसर फॉर दिस। इन ए वेरिएबल साइज मतलब पार्टीशंस की साइज वेरी हो सकती है, बट अप्रोच इज फिक्स पार्टीशन। ऑब्जर्व दिस, दिस फिक्स पार्टीशन, दिस इज फिक्स पार्टीशन, fixed partition memory management. Partition sizes may be of very variable size. Partitions may be of variable size. Internal, when do I get internal fragmentation? Sufficient memory is available to run a program, but it is scattered. No, this is not internal fragmentation. Insufficient memory is available to run a program. No, that is not internal fragmentation. The partition allocated to a program is larger than the memory required by the program. This is internal fragmentation. ठीक है? The partition allocated, जो allocate कर रहे हो आप partition, that is larger than the program size. जो left over memory होगी वो होगा internal fragmentation. So therefore the correct answer for this is C. A program is larger than the size of memory on the computer. जब तो आप program ही allocate नहीं कर सकते हो तो कहाँ होगा fragmentation? So therefore correct answer is option C. ठीक है? So these are some of the questions. So these questions we have already done with regard to linking. So other questions we'll take up in the next session. So we would like to close for today's session. तो नेक्स्ट सेशन में मैं आपको बात करूंगा विथ रिगार्ड टू टेक्निक्स ऑफ नॉन कंटीन्यूअस एलोकेशन, जहां पर मैं डिस्कशन स्टार्ट करूंगा द कॉन्सेप्ट ऑफ एड्रेस स्पेस, लॉजिकल एंड वर्चुअल, लॉजिकल एंड फिजिकल एड्रेस स्पेस, एंड देन फाइनली आई विल टेक अप पेजिंग टेक्निक, पूरा बेसिक फंडामेंटल बताऊंगा, पेजिंग, परफॉर्मेंस ऑफ पेजिंग, ये सब हम डिस्कस करेंगे नेक्स्ट सेशन में। तो आज के लिए इतना ही बच्चों, थैंक यू सो मच, टेक केयर एंड हैव ए वंडरफुल प्रिपरेशन जर्नी।